Total ammonia or ammonia can be a critical water quality parameter because it can be toxic to the fish or whatever aquatic organism we're culturing. Ammonia comes from the breakdown of feed, the digestion of feed, or the breakdown of wastes in the pond, uneaten feed and feces. So ammonia is constantly being produced in the pond. It's being produced at higher levels when we're feeding the fish heavily. The critical thing about ammonia and its toxicity is based in pH and temperature. As temperature goes up and as pH goes up, more of the ammonia ion is converted into unionized ammonia, which is the toxic form of ammonia. So when we measure ammonia weekly or biweekly, especially when we're feeding heavily or maybe our bloom has changed because our algae in the pond and our bacteria consume the ammonia as a nitrogen source for their growth. But when those ammonia levels are high due to high feeding or bloom die off, then we need to measure that. We need to look at it based on pH and temperature to determine possible toxicity. In reality, when a pond is fed at the right amount and we have good aeration and good algal production in the pond, we seldom ever have ammonia problems. It's when we overfeed or we have an algal die-off that we often have ammonia spikes, and ammonia can be toxic. It can kill fish.
As you can see behind me in this pond, we've had a fingerling die-off overnight, and we've also got an accumulation of scum on the surface of the water indicating that we might have had a phytoplankton die-off recently. So one of the problems with a phytoplankton die-off is that we end up with a high ammonia concentration in the water afterwards very frequently. So the first thing we're going to test for this morning will be total ammonia nitrogen. We start with a completely clean test tube. We have to make sure that we don't have any other water in our test tube, no other reagents from previous tests in our test tube. Start with a clean sample, 5 milliliters of water. And with this test, we use 2 different reagents. The first reagent's 4 drops. And now we need to wait for a minute for those reagents to work in that water sample. Now we're ready to add the second reagent. We add 12 drops. And what we're looking for in this test is a color change to yellow if ammonia is present. As you can see, we got a color change on our sample after we added the second reagent, indicating we've got a high level of total ammonia nitrogen. And ammonia can be very toxic to fish under certain other water quality conditions, so we're going to suspect this as being at least part of our problem with this fish kill. Now with the Lamont kit, the way we determine the ammonia level is with what they call an octaslide viewer. We insert the sample into the plastic apparatus here and use a color comparison strip to determine what our actual ammonia level is in that water sample. Unfortunately, with this particular water sample, our total ammonia nitrogen concentration is too high to read on the scale that comes with this kit, so we'll have to dilute our water sample to get back down within the range of the scale. So to do this, we're going to start with a 10 milliliter sample of our pond water and 10 milliliters of distilled water that will give us a 50-50 mixture, which should in effect lower the ammonia by 50% and thus allow us to test this water. As I mentioned before, it's very important that we rinse the testing equipment in the water that's actually going to be tested, so that any water that remains is actually the water we want to be in there. So again, we'll start with our 5 mLs of sample water. This is now our diluted sample water. And we'll do the test again, just the same way we did it before. starting with the 4 drops. We'll cap that and wait a minute, and then we'll add our second reagent. The minute's up, so now it's time to add our second reagent. We add 12 drops of this reagent. We'll cap it and mix it. As you see, we still have a yellow color on the sample, but it's not as dark as it was, so we should be able to measure this on our OctaSlide. Should stay within the range of that scale. So we wait 5 minutes. As we had hoped, diluting this water sample did allow us to read the total ammonia nitrogen concentration in this sample. We diluted the sample 50-50 with deionized water, so our 2.0 reading that I'm getting now will be multiplied by a factor of 2, giving us a total ammonia nitrogen concentration in this pond water, 9 o'clock in the morning, of 4.0. Now, under certain water quality conditions, that amount of ammonia can be toxic to fish. We now need to check the water temperature as well as the pH to determine whether or not a toxicity was present and possibly killed these fish.
Ammonia toxicity is dependent on the pH and temperature of the water. Ammonia has 2 forms, an ionized molecule, called the ammonium ion, and an unionized molecule. When ammonia dissolves in water, it forms an equilibrium between the ionized and unionized molecules based on pH and temperature. Unionized ammonia can be toxic to fish at high concentrations. The amount or concentration of unionized ammonia increases as pH and temperature increase. So ammonia toxicity can be a problem if a high concentration of total ammonia is present and pH and temperature are elevated.